So we're going to begin what is our very short but sort of straightforward unit on chemical bonds. There's really only three kinds, and there's only two that we're going to explore in depth. So a chemical bond is the force holding atoms together in a compound or a molecule. So far we've dealt with elements, and we've dealt with atoms, and we've dealt with them being individual and on the periodic table and their patterns. And we know that they want to try to get those 8 electrons, but in order to do that, there has to be different ways of transfer and sharing electrons. And this is what holds our compounds together. We can write the names of them now, so we know how to write those formulas, but what's really going on when they're being bonded together? So our first type of bond is called an ionic bond. And ionic bonds generally form between atoms of metallic and non-metallic elements. And so these are our elements on the left side and our elements on the right side of the periodic table are bonding together. They're formed by the attraction between ions resulting from a transfer of electrons. So if we think of our sort of very traditional example of sodium chloride, we know that Na wants to become +1. We know that Cl wants to become -1. And so Na, who has this extra electron that he doesn't want, hands it over to Cl, and that's an actual transfer of electrons. They are soluble in water, and they conduct electric current in the molten state as well as in solution. The word for conducting electric current in solution is electrolytes, and that's a vocab word that you're going to need to know for this unit. And ionic compounds also have high melting points. So these are all of our properties of ionic bonds. Can ionic bonding explain Cl2? Because Cl and Cl like to bond together, and we're going to get into that more in detail. Can it explain why Cl and Cl like to be together? Because Cl is a -1. Why would it want to go with another one? Ionic compounds are solid are typically solid crystals. Chlorine is a gas. You've heard of chlorine gas, and at room temperature, chlorine is a gas. Ionic bonds occur between a metal and a nonmetal. Well, chlorine is nonmetal to nonmetal, so chlorine is two nonmetals put together. Chlorine has 7 valence electrons, and if we take an electron from a chlorine and give it to another chlorine, well, that's great. One of the chlorines would have 8, but then the other one would only have 6. So this isn't going to work to explain how bonding takes place in chlorine. And so ionic bonding is sort of our what we think of. You have too many, you have too few, let's transfer an electron. And then because of electrostatic forces, I'm positive, you're negative, we're still going to hang out together. Okay? But we have a whole different kind of bonding called covalent bonds. And covalent bonds are generally between our nonmetals. So this is where that bonding comes in. Remember, we talked about everything that's named mono, di, tri, all of our special naming with nonmetals, and all of a sudden we didn't care about charges. Well, they're forming a totally different type of bonding. Those are covalent bonds. So if you see that mono, di, tri, that kind of stuff, that's a hint that we have covalent bonds in place. They share electron pairs. Some of their properties are they have low solubilities. They do not conduct electric current in solution. They have lower melting points. And when atoms bond covalently, we refer to them as a molecule. So when the whole formula is together, when we have something like carbon dioxide, we have CO2, we're going to refer to that as a CO2 molecule. To give you a picture of what this looks like, it's electron sharing. So if we have a nitrogen molecule, because now it's covalent, so we're going to call it a molecule, we have the 2 inner electrons for each of the nitrogens, and then we have this sort of group of shared electrons, meaning they can sort of travel in a figure 8. They can go around either one of those nitrogens. Hydrogen, here the same thing. They're sort of buddied up together, sharing those electrons. And it results in referring to these as molecules. So based on our learning of the periodic table, atoms need electrons to complete their outer shell. They want that magic number. They both want electrons. They all want to be happy. They all want to be complete. The goal is to get 8 electrons. And if you're hydrogen or helium, the goal is to get 2, because they only have that first ring. But everybody else wants 8. And we count shared pairs and unshared pairs of electrons. As we get into drawing these later on this week, you'll really see how we're going to count those shared and unshared pairs. Neither of the elements is strong enough to remove an electron from the other element. So in ionic compounds, one of them wants the electron so bad and one of them wants to get rid of it so bad that there's an actual transfer of electrons. In covalent, no one's sort of the bully enough to actually take that electron away, so they do sort of share. It's a tug of war sharing of electrons. And so what kind of atoms form covalent bonds? Well, what kind of atoms are in these molecules? If we look here, think about how we would name all of these, okay? We would name this carbon dioxide, dihydrogen monoxide, nitrogen trihydride. Do you know what the common names for both of those are? I'm guessing you know this one is water. And the common name for this one, I've started to point it out a lot. We're just going to get to know it. This is ammonia. Okay? So these are all nonmetals. All of these up here are nonmetals. And so they typically have 5 or more valence electrons because they start at group 5 over there, 4 or 5. And they have a high electronegativity. Okay, so these are our elements that are going to form covalent bonds. As the days progress, we're going to get into looking at how electronegativity comes into play with determining how electrons are taken and shared. We're going to refresh ourselves on our dot diagrams, and we're going to go through a lot of examples so that you can see how these elements are sharing or transferring electrons, and then ultimately what shape they're going to become, because all of these molecules are bonded together three-dimensionally, so we need to look and see what sort of shape they're going to form.